Today we are going to discuss about CET and JEE NEET questions on chapter current electricity. First question, the resistance of a piece of annealed platinum wire can be used for the measurement of temperature because its resistance, option A, varies uniformly with temperature, option B, remains fairly constant with change of temperature, option C, increases in sharp but known steps with temperature, option D, oscillates with temperature. Here, platinum is a metal. If resistance of a metal increases with the temperature and if temperature increases, resistance of the wire also increases. Therefore, it will varies uniformly with temperature. Its resistance, platinum resistance, will be varies uniformly with temperature. Option will be answer A, varies uniformly with temperature. Second question, state which one of the following materials is most suitable for making coils of resistance box. Option is option C, because resistance box are made up of coils in the resistance box are made up of constantan, manganese and nichrome wires. Hence, in the option, 4 options will be aluminum, tellurium, manganese and tungsten. Hence, option will be option C. Third question, a diameter of a circular cross section of area of a diameter 0.08 millimeter is made up of material of whose specific resistance is 16 micro ohm centimeter. If the resistance of wire is 21 ohms, its length is. Now, I will consider wire with a cross-sectional diameter 0.08 millimeter made up of material whose specific resistance is 16 micro ohm centimeter. If its resistance is 21 ohm, then what is its length? We have to find out the length of a wire. Diameter of wire should be 0.08 millimeter. That should be written as 0.08 into 10 power minus 3 meter or 8 into 10 power minus 5 meter. 16 micro ohm centimeter will be written as 16 into 10 power minus 6. Centimeter should be converted to meter. 10 power minus 2, that will be equal to 16 into 10 power minus 8 ohm meter. I need the diameter radius. Then radius will be equal to diameter divided by 2. Hence, that value should be 8 into 10 power minus 5 divided by 2. Now, I need the area of cross section of a wire, that will be equal to pi r square. Now, resistance is directly proportional to length of the wire and inversely proportional to area of cross section of the wire. Hence, the equation will be written as R equals rho L divided by A, where rho is specific resistance or resistivity, R is resistance of the wire, L is length of the wire, A is the area of cross section of the wire. Now, I need the value of length. L equals R A divided by rho. A should be pi r square. L equals R pi r square divided by rho. Hence, L should be equal to, value of R is 21 ohm, pi should be 22 by 7 into R square, radius should be 8 into 10 power minus 5 divided by 2 whole square into, here rho will be in denominator, rho will be 16 into 10 power minus 8. Now 2 4s are 8. 7 3s are 21. L equals 3 into 22 will be 66 into 4 4s are 16 into 10 power minus 10 whole divided by 16 into 10 power minus 8. 16 get cancels. L should be equal to 66 into 10 power minus 2 meter, that will be converted into centimeter, that is 66 centimeter. Option will be option A. Answer should be like this. Now, we are going to next question. The specific resistance of the wire is 1.21. The specific resistance of the wire, 1.21 meter long, 1.21 meter long, 1.1 millimeter diameter, length will be 1.21, diameter should be 1.1 millimeter, that should be converted into meter, that will be equal to 1.1 into 10 power minus 3 meter, and having total resistance of 126 ohm. Resistance will be 126 ohm. Therefore, we have to find out specific resistance. Now, we know that R equals rho L divided by A. Rho should be equal to RA divided by L. Area of the wire should be pi R square. R into pi R square divided by L. Now, we know that the diameter, but radius will be D by 2, half of the diameter. That will be 1.1 into 10 power minus 3 meter divided by 2. Now, I will substitute the values. R is 126 ohm. Pi will be 22 by 7. In denominator, length should be 1.21 meter. And R square will be, R should be, radius of the wire should be 1.1 into 10 power minus 3 divided by 2 with its square. Now, rho equals 126 into 22, 1.1 into 1.1 should be 1.21 into 10 power minus 6 divided by 1.21 into 7 into 2 2s are 4. 1.21 get cancels. 2s are 11s are, 2 6s are 12, 2 3s are 6. 63 should be cancelled by 7. 9 times 9s are, rho should be equal to 9 into 11 into 10 power minus 6. So, rho should be equal to 9 11s are 99 into 10 power minus 6 ohm meter. Therefore, option will be option B, 99 into 10 power minus 6 ohm meter. Answer should be like this. Next, fifth question. An electric iron has a resistance of 10 ohm. How much heat energy produced in 10 minutes if the current is 10 ampere? Here, the question will be simple. How much heat energy is produced? Heat produced per second will be written as power, that will be equal to I square R. I square R. Here, resistance value should be 10 ohm. Current will be 10 amps. Hence, heat produced per second or power should be equal to 10 square into 10. P equals 10 tens are 100. 100 into 10,000, 1000 watt or joule per second. Now, heat produced per second, or here heat produced in 10 minutes means heat produced or heat energy produced in 10 minutes means heat produced per second into time. T will be 10 minutes. 1000 into 10. Minute will be converted into second with 60. That will be equal to 6 ones are 6. 6 ones are 6. Here 3 zeros, 4, 5 into 10 power 5 joule. Heat produced in 10 minutes will be 6 into 10 power 5 joule. Option will be option C. Answer should be like this. Next question, question number 6. Which of the following is a correct statement of Ohm's law? Here Ohm's law states that current in a conductor is directly proportional to the potential difference provided temperature and other physical conditions constant. Here in option C, all physical conditions remaining constant, the potential difference across that conductor is directly proportional to the current in it. This will be a correct statement. Therefore, Ohm's law statement is option C. Seventh one, how much charge flows through a lamp in 1 hour if the current through it is 0.5 ampere? Here, how much charge? We have to calculate charge in 1 hour. Time should be 1 hour. 1 hour, that will be converted into second, 3600 second. Current should be 0.5 ampere, or it will be written as 1 by 2 ampere. Now I want to find out charge. We know that I equals Q by T by definition of current. Q equals I into T. Now 1 by 2 into T will be 3600 second. 2 18s are, here Q will be equal to 1800 coulomb. Answer will be option C. Answer should be like this. Next question. If a flash gun of camera operates for a millisecond and during this time 0.05 coulomb of charge flow, then current will be. In a flash gun camera, time will be given as millisecond. Milli means 10 power minus 3 second, and charge will be 0.05 coulomb. Current, we have to find out the current. I equals Q by T by formula of the current. Q will be 0.05 coulomb divided by 10 power minus 3. Or we can shift numerator by 5 into 10 power minus 2 divided by 10 power minus 3. Here 5 into this 10 power minus 3 will be shifted to numerator. It becomes 10 power plus 3. If bases are same, we will add powers. Hence plus 3 minus 2 will be 10 power plus 1. Hence 5 into 10 will be 50 amps. Option will be 50 ampere, option D. Ninth question. At 1000 degrees Celsius, the resistance of a wire is At 1000 degrees Celsius, the resistance of a wire is found to be 4 times its resistance at 0 degrees Celsius. Calculate the temperature coefficient of resistance of the material. Now, here at 1000 degrees Celsius, temperature T1 should be 1000 degrees Celsius. Initially, its resistance at 0 degrees Celsius means initial temperature should be 0 degrees Celsius. Here, the resistance of wire should be R1 should be equal to R times the 4 times the resistance, initial resistance R. Therefore, calculate the coefficient of temperature of material. Alpha should be we have to find out the coefficient of resistance. Now, by the formula, RT equals R0 into 1 plus alpha into delta T. Delta T should be equal to T1 minus T naught. T1 should be 1000 degrees Celsius and T naught should be 0 degrees Celsius. Therefore, delta T should be 1000 degrees Celsius. Here, T1 RT should be 4 times R. Therefore, 4R equals R naught should be R into 1 plus, we have to calculate alpha, coefficient of temperature. Delta T should be 1000. Now, R and R get cancels. 4 equals 1 plus alpha into 1000. 4 minus 1 should be equal to 1000. Alpha should be equal to 3. 1000 alpha should be equal to 3. Alpha equals 3 by 1000. 3 into 10 power minus 3. Alpha will be equal to 3 into 10 power minus 3 per degree Celsius, or it can be simplified as 0.003 per degree Celsius. Option will be option C. Option C. Next question. When a metal is heated, its resistance in options we have may increase or decrease. Option B remains constant. Option C decreases. Option D increases. In a metal, when metal is heated, electrons or free electrons will move randomly. Therefore, its resistance increases. Hence, option will be option D. Next question. An example of a non-ohmic device is, in options, option A is potentiometer wire, option B is triode, option C is platinum resistance thermometer, option D is copper wire. Since non-ohmic device means the devices which does not obey Ohm's law, triode, semiconductors, diodes, so vacuum tubes, those are an examples of non-ohmic devices. Hence, in option B, triode is an example for non-ohmic device. Next question. A wire of resistance R is uniformly stretched until its resistance is halved. Its new resistance is. We know that the wire has a volume that will be equal to pi R square into L. Since a wire has a length and area of cross section, area of wire should be in circular. Therefore, we have to write pi R square. Now, resistance should be R, which is uniformly stretched, and again, if its resistance is R, then its radius should be small r. If its radius should be halved, if R dash will be equal to R by 2, then what is its new resistance? We have to find out the new resistance, but I don't know the new length of resistance wire. Now, I want to find out L dash first and then R dash. Now, I have volume pi R square L, that will be equal to pi R dash square L dash. Since volume of the wire should be same, hence R dash should be R by 2. Pi get cancels. R square L should be equal to R square by 2 2s are 4 L dash. R square get cancels. L dash will be equal to 4L. Now, we know that R equals rho L divided by A. Rho L divided by A. A means pi R square. Rho L divided by pi R square. Call this as equation number 1. In new resistance, rho L dash divided by A dash. A dash should be, A dash will be pi R dash square. Now, rho, specific resistance will be same, rho into L dash will be 4L divided by A dash should be pi, R dash square means R square divided by 4. Now R dash should be equal to, this 4 will be in the terms in denominator of denominator will be goes to numerator. Therefore 4 into rho L divided by pi R square. Call this as equation number 2. From equation 1 and 2, we have to substitute the value of equation 1 in 2. Therefore R dash should be equal to 4 4s are 16, 16R. Hence option will be option C. 16R is answer. Answer should be like this. Answer should be like this. In similar way, we are doing the problem 13 with same data given, but in same method as before. Here the radius will be n times r. Then we have to find out L dash, and the new resistance will become r divided by n power 4. R divided by n power 4 we have to do as assignment.